SwiftKey, which is a maker of a third-party keyboard on iOS and Android as well. Yeah, so this is SwiftKey. We shipped SwiftKey for iOS last year together with iOS 8, and we managed to get noticed by Apple and The Verge. And so for most people, custom keyboards is sort of a niche product. But I'm going to ask you a question. What do you think is the most used app on your iPhone?
Twitter.
Maybe. But for most people, most normal people, it's out there, non-developers. It's probably this guy. That's the Apple keyboard, and we're basically trying to make it this, which is SwiftKey. And why would we really care about that? Well, let's look at some of the cases where you actually use your keyboard when you use your phone. So you talk to your friends on iMessage or any other messengers. You update your status on Facebook, Twitter. You write important emails, obviously. You put down reminders, to keep you on track. When you're on the go, you really want to edit Google Doc documents. Well, obviously, you want to be, in touch with your GitHub buddies. And you're hungry, you look for something to eat. You're somewhere stuck in the middle of the night, you need to get home. You use Uber with a keyboard. And then you're in the mood, you just want to listen to some Lady Gaga. Of course, you have to type it out. So basically, the time you use, the time you spend using your keyboard is most likely greater than the time you spend using any other app, really. So we feel like that it's a huge opportunity to build something great and really useful. So we were really excited to get the API last year with iOS 8. And really, according to Apple, how they described it, the responsibility of a custom keyboard is to respond to taps, gestures, and provide text. So that's all it is. It's basically a box. You take gestures in, and you provide some text. And everything in the middle is your responsibility. So how would you go around installing such a keyboard if you actually manage to find one? Well, that's the thing. It's like for most normal apps, just downloading the app from the App Store is enough to get it set up. Not really for custom keyboards. So you get in this process where you have the Apple keyboard, you already downloaded SwiftKey, and you have to go to General, Keyboard, Keyboards, add a new keyboard. You choose the keyboard you want to use. You have to go in again, allow full access, allow, and you go back and you're finally set up. So this can be slightly complicated, but it works. But since I spent the last year and a half working on a custom keyboard, I really want to talk more about how it works under the hood. So this is a screen from the Apple documentation, which describes sort of how you're supposed to really go about creating one. So a custom keyboard is just a type of an iOS 8 style extension, which you just create in your app, and it gets distributed with your app. And the way it really works is that it gets presented in a host app, and it provides the text for the host app through some API. And pretty much, they actually show just this blank page because really, you can do anything you want with your keyboard. The only thing that a custom keyboard needs to have to get approved by Apple is to have a next button key or the globe key. Where Apple solves it like this with the globe key, and most other keyboards really have a similar button in that area. So, as I mentioned, there's some way to really talk to the host app from your keyboard. And the API is really simple, in fact. This is not all of it, but it's actually the most important parts. So the way the keyboard talks to the system is through basically the way you insert text is by calling insert text and passing the actual string. So you can really only pass an attributed string. That's all you can do. Then when you want to delete, you have one call called delete backwards, which deletes one character only. So if you want to delete a word, you need to know how long it is and how many times you have to call this. And then when the user hits your globe key or whatever, you just need to call advanced to next input mode, which tells the system that the user wants to see the next keyboard in their list. And when it comes to callbacks back from the system, you get text to change, which basically means that the app or the user in the app triggered some change to the underlying text in the text field. And you should basically reload again your internal state. And that you do that by asking for the document context before input, which again is just a string, and that's the contents of the text field that the user is typing into. Excuse me. So I mentioned that there's some keyboard, there's a host app, there's a containing app or container app. So this is roughly how they relate. You would download a custom keyboard with a normal app. So that would be the container app that contains the custom keyboard. And then when you're, for example, here typing in Evernote with your SwiftKey keyboard, Evernote and the keyboard talk through the API I just described. And by default, when you really think about how you would implement such an app, you always come to needing your container app and your keyboard extension to communicate in some way, to share some data. So that's the sort of the first trick with custom keyboards, because by default, you cannot really share data between your keyboard and your container app, or between the keyboard and the internet. And that limitation is called full access. And the problem with that is, when you just imagine just even the simplest things you would want to do in your container app is just change some preferences, or change your theme, or download new languages. All that stuff is impossible without full access. So when you actually allow full access, which we basically have to ask every user to do, because otherwise there's not really much we can do, that allows the keyboard to talk to the shared container, which is someplace on disk, where both the container and the keyboard can access, and also talk to the internet. So the reason why it's really useful for the keyboard to have access to the internet is to mainly send crash reports, and also we have like an opt-in cloud feature, so you might want to sync sort of your language insights between your devices. I don't really love the name full access, to be honest, because we've seen that it can really freak people out, especially on the internet. We've seen a lot of things what it apparently means, that the keyboard can access everything on the phone and stuff like that. So that's not really the case. Full access just means that our keyboard extension can talk to our container app and to the internet. That's it.
Sorry, but it does mean you can send what I type to a web service.
Yeah, you could technically, and that's really important. Actually, thank you for bringing that up. That there needs to be really good trust between the company making the keyboard and the users, and that's really a job for you as well. But I feel like that's really a case for all apps, because we're always putting in some personal information in all apps, and you need to really build trust between your company and
yeah,
your
except
users.
that in your case, it's every app. It's not your app.
Yeah, absolutely.
You can
Absolutely.
put your keyboard on the front of my banking app.
Yeah,
so,
yeah.
so it is a different world.
Yeah, yeah.
Well, don't secure password fields and so on specifically disable custom keyboard.
I'll get to that.
Okay, sorry.
Sorry. So yeah, I mentioned the share container place. So that's basically just place on disk that all your apps and all your extensions can access. So that's what you use. You just need an entitlement in both your app and your extension to be able to access it. And you basically just put your data there from the keyboard, let's say, and you can pick it up from the container. So since it's just a place on disk, if you imagine that your keyboard extension would be up in your own app, and you would want to change some preference, that kind of is annoying, because you can just save some file on disk, but it's not going to get picked up immediately. So you can actually use something called dark notifications for this, which is a cross-process notification, which doesn't have any payload, so it still isn't proper XPC, but it really can help with this, because we basically just register one string being like our preference is changed. So when you save something, the other process can immediately really listen to that and load the preferences again. So that's actually really useful for all extensions, not just keyboards. So there are some limitations to what custom keyboards can do really compared to the Apple keyboard. And most of these limitations Apple really put in on purpose, and most of them really make sense. So I'm just going to go through them. One of them, which was already mentioned here, is that even if you install a system-wide custom keyboard, it doesn't guarantee you're always going to see it everywhere. So one of the big examples is secure text fields, where you basically, most apps put passwords and very sensitive information. So that's awesome because even for us, we don't have to worry about that because we don't get launched. It's the system keyboard that gets presented in that case, and the user can, I guess, feel more more secure. And another case is that apps can actually explicitly disallow third-party keyboards. In this case, so I know some enterprise sandboxing apps need to do this for some regulation, but that's also an opportunity. And for in the case of lock screens, when you have your passcode enabled, actually, and you get an iMessage and want a quick reply to it, a custom keyboard will not be presented. That's for encryption reasons. There's a couple of more places, more things that custom keyboards cannot do while the Apple keyboard can. One of them is draw above the frame of the keyboard. We cannot do this. The system does this with these little pop-ups above the keyboard itself. Another one is inline corrections and predictions. So we don't have any way to really hook into the system to show these things. And one of the biggest ones is the microphone access. So we don't have access to the microphone. So even if we wanted to really implement the dictation feature, we cannot. So that's probably one of our biggest feature requests. And we're hoping that Apple adds it to the keyboard API and we'll be able to hook into it. Now, so Apple put in some limitations on purpose. Unfortunately, they also sort of put in some bugs, not I think not on purpose, but when the keyboard API was presented last year, we were sort of disappointed because it was really buggy. There were a lot of issues with it, and that's sort of really how the reputation of custom keyboards on iOS has been really heavily affected by. So that has been getting much better throughout the last year, especially iOS 8.3 made it much better. But there's still some issues that are still in the API, and two big ones are revert and hang. So revert is the name of a bug where basically you are expecting your custom keyboard to show up. So in iMessage, just normally typing, and suddenly the Apple keyboard pops up. And that basically happens by, randomly, and we don't really know, like it's not really our fault, and Apple knows that it's a bug, but basically it can happen at any point, and we do get complaints. It can happen to more people, sometimes less, so we really don't have a way to fix that. The other one is the hang, which is not as frequent lately, especially in iOS 9, but basically means that the user wants to start typing in a text field, and no keyboard pops up, not even the Apple keyboard, so it just keeps hanging, and there's nothing in the place where the keyboard should be. So these are the two big bugs in the API. So you might say, like, yeah, maybe you're just making excuses because you don't want to fix your bugs. I mean, that's not really the case because we actually made an experiment and we created a completely blank keyboard, so just an empty extension with just keys to tap, and that was it. There was no persistence, no networking, no nothing. And we used it for a week, our team. So that was awful, to be honest. No correction, no prediction, no flow, no nothing. And we actually started seeing these bugs there as well. So it was basically a keyboard that had this much code, and all it was really typing into a text field, and we saw these bugs there as well. So fortunately, Apple knows about this, and hopefully they'll fix it as soon as possible.
What is their incentive to fix it?
That's a good question, actually, because they make their own keyboard, and they also make an API. But I think it's the same case for all APIs. If they opened it up, it being buggy really hurts their platform, because they should either keep it closed or they should make an API that really works. So it's mostly just the functional high ground stuff and just really making good software, I think. But I think that they're really dedicated to really doing this. Like, we're open the API, we're gonna fix it. It's just taking a long time. And so I mentioned bugs, I mentioned limitations put in by Apple where you can't do anything completely. There are also limitations when it comes to how much you can just do something. So these things really lead to interesting challenges and basically the things you spend most of your time on when you're building a custom keyboard. And probably the biggest one is pretty strict memory limits. And the other one is unavailability of certain APIs. One of them, probably the biggest one, is UI application. So you know how the API open URL is actually on the UI application. We don't have that. That means that we cannot open our container app from our keyboard. which would be really nice if you could just go to like, I want to see more settings, and it would open the container app. So that's basically just missing from that. I want to talk about the memory limit more. So last year with the API, we found out basically during the beta period that our keyboard was getting killed randomly. And in fact, it wasn't really random. It was put in by Apple. There was a very strict limit, around 50 megabytes. So this number, don't quote me on this, it's not exactly 50 megabytes. It's mostly what we sort of figured out how much it roughly is. And the way this memory limit works on iOS is that whenever your extension, well, in this case, your keyboard extension, even touches that limit, even for 1 millisecond, it gets terminated immediately. So it's not like with normal apps when you get some grace period, and if you're using too much memory, you eventually get killed. In this case, even if you use a couple of bytes over, you immediately get killed. So that's the way the Jetson process in iOS works. And we really spent months on optimizing this. And I'm going to talk later about how you can do that as well for your extension or your keyboards. Yeah, as I mentioned, once you go a little bit over, you immediately get terminated, which just results in your current keyboard going away and the next keyboard popping in.
Do you know if that applies to all extensions?
I think so. I'm not sure if it's the same numbers for extensions, but I know there are strict memory limits for all extensions. Where it usually makes sense, because they really are presented together with, sort of, when you have the Today widget, for example, you have 4 or 5 of them on screen, so they can't all consume 500 megabytes of memory. But the fact is that most modern iOS devices have 1 gigabyte of RAM or more. And that little slice there, that's the 50 megabytes we get, really. Even though when you're really typing on a keyboard, you're not really doing anything else. So it's basically the one process that matters, and we still get 5% of the memory. So we could really just complain about it, or we could do something about it and really do our best in those 50 megabytes. So we came up over the year with a couple of workarounds or ways to mitigate this. The first one, and the biggest one probably, is something called memory mapping. So just for those who don't know, there is a way on all the Unix systems, I think, to take a file on disk and present it in memory as if it were already loaded. What it does is basically it lazily loads those pages of memory on demand. So you have a file that's 20 megabytes, and that's nicely linear memory, and then someone accesses in the middle of it, only the little piece gets loaded, and then it gets paged back down. So even though it looks like you have a 20 megabyte file in memory, actually it's not all loaded. That means that your process doesn't get killed. So without memory mapping, we would not be able to ship now, especially because we have a feature called multilingual typing in SwiftKey, which means that we load multiple language models at the same time, and you can type your language, and we detect which one it is in and adapts with corrections. So yeah, as I said, we memory map a lot of things, trying to memory map even more. And we actually found out that iOS does this a lot as well with images and with a lot of big resources. Instead of loading them directly, they actually memory map them and lazily load them on demand. Another one, which is something called caching views, seems a bit of an anti-pattern in normal app development. But imagine that you have a frequent screen with a table view controller. And when you leave the table view controller, you would actually keep the view around. Let the view controller be deallocated, keep the view around. And once the user comes back, you would pop that in again. So the problem, or the reason why we have to resort to things like this, is because creating views spikes memory a lot. And as I mentioned, spikes, even just spikes, are really bad when it comes to the memory limit. So by caching views, you actually avoid deallocating and reallocating things, which really helps to avoid really like big jumps in memory. So it's more like stable level, which is much easier to optimize and reason about. Another good one that we found a couple of months ago, we were using core data for something. And that was that core data, just an empty stack of core data, takes 4 megabytes of memory. Yeah, 4 megabytes of memory, just having an empty stack when you create, just the models up to the context. And all that takes 4 megabytes of memory, just the internal state. So we had to get rid of that because 4 megabytes of memory for us is huge. I mean, there's months of optimizing. So we also found out that basically to be safe and not to crash when you're typing, which SwiftKey doesn't really anymore. It used to, in the beginning before we learned all this, is to really stay under like 30 megabytes of memory, and then you're going to be safe. If you mitigate spikes and you stay under 30 megabytes, you're not going to have these problems that when you're going to be crashing on screen. Yeah, as I mentioned, watch out for spikes, anything that could cause spikes. So transient data structures, all that, really profile it. We basically, you need to make instruments your best friend whenever you're working with extensions, because of all these constraints of CPU time and RAM. Is for us, especially with memory, allocations and the VM tracker tools are super useful. So these you basically use all the time, and allocations tells you exactly every single object that was allocated, who allocated it, and how much memory it's taking. So that really helps you a lot. VM tracker gives you a bit of a better image of how much actual memory is paged in. How I mentioned the memory mapping, you would be able to understand how much of that file is paged out and paged in. So all of this is really necessary to be able to build a really good extension, because in case of keyboards, for us, extensions are not like something nice on the side. For us, it's the main product, and the container app is sort of on the side just for customization. And I also want to talk about testing a bit, because as with all apps, basically when you build something, it's working, you want to make sure that it keeps working. And it's a bit tricky, as usual, with keyboards or with extensions. So there's no testing bundle that you could create in Xcode for custom keyboards. So the way you want to do it with all extensions is to basically put all your code into an embedded framework that you're going to embed in both your container app and your keyboard. And then you can write code, you can write tests against your container app and make sure that all the logic is working. However, there are still some small weirdnesses that only happen when the keyboard is running, or while the code is running in the keyboard itself in an extension. So we developed a very hacky way to measure some sort of memory of the extension by actually triggering the keyboard in a test that basically gets loaded up, and then we use the shared container to send messages to it, what to type, and then to sort of capture resident size memory and send it back. So we sort of built something like this. It's a bit hacky, but it basically gave us sort of a good way to measure how much memory our keyboard takes during typing and during loading. What I mentioned here, resident size, that's just one measure of memory on iOS, which is not terribly reliable when it comes to Jetsam and your app being killed, but it's the closest thing we get. Unfortunately, there's no API to measure memory this way, but hopefully there will be soon. And the last way, last thing here is a way of making sure that you want to be able to change your rendering code easily without being afraid that you're going to move something pixel to the left, pixel to the right. So we really rely on pixel perfect testing, which means that we run tests. They take screenshots of the keyboard in a lot of cases, and then we compare them to our references, and we actually subtract them pixel by pixel, so we know exactly if anything has moved. And we actually caught quite a lot of bugs like this. We wouldn't just let it out because it wasn't to the last pixel exactly how we actually wanted. So that was a lot today, but I just want to recap again. Custom keyboards, and I think extensions in general, are really underrated, but they're a great opportunity to add values to your users, really. In the case of the keyboard, I think you really can write the most used app on someone's phone, and we really shouldn't think of real keyboards just a utility, because most people consider it something that's not great, it's not bad, it's just there. We don't think about it. So really, SwiftKey is trying to make that exciting, but also really useful. So for me, even if I wasn't working at SwiftKey, I would not be able to go back to the Apple keyboard anymore, because it's just too slow, really. You get used to this much faster typing and much easier typing that we basically wanted to show that there is a way to do this much, much better. So we just need to basically make people understand that even a keyboard is something you can switch, try out, abandon if you don't like, but just try it out and really see how it can make you much more productive on your phone. And as I mentioned, there are still hard problems to be solved, which is also very exciting, because it's not just writing boilerplate code. and we actually, in a lot of cases, really solve problems for the first time on the platform. So if that sounds good, we are actually hiring iOS developers. What we can offer is, great team and hard problems. I mean, I don't know what else really. Yeah, I always like to say that there's a lot of these things, or most of these problems that we were solving last year and are still solving now, you can just find answers to on Stack Overflow, which in a way is sort of satisfying because you can be the person answering those questions for the first time. But yeah, there's a huge opportunity to really build something that people use all the time. Again, it's slightly utility, people don't realize it, but you can really make people much more productive and make something that really matters to them. And that's it for me. Thank you for listening.
So, questions? Anyone here?
You go first.
Oh, they're so polite.
How much of the context of what's being editing do you have access to in the keyboard? Like, if I put the insertion point in the middle of a word, in the middle of a sentence, how much of that does
Yeah,
keyboard
yeah,
have
yeah.
access
Can you
to-
hear that at the back? Is
to
there-
change?
I can repeat it.
No, they said they're right, but yeah.
Cool. So
Maybe if you're not.
we basically get most of the stuff before and after, just as text. So even if it's attributed, we can just normal and a string. So we just get, we can load the document context before input, and there's also a method to call it after input, but we don't really use that for anything, really. We don't use it at all. We just use the before input to be able to sort of load our internal states and use that. But I think in our case, what we actually do, we only load up like the last 6 words or anything to load up, to the internal state, and then you basically type. But technically, you should have access to. It used to be that you could only get access to in the last line. So if there was a new line character, you wouldn't get anything before it. But I think now, we technically get everything, but we don't use it.
And how much of that can you actually replace from what the user's typing or affect?
We can only replace things at the insertion point, and we can move the insertion point, even though we mostly don't do that. But you could move the insertion point. So you could really replace anything. If you move your insertion point, then you deleted something, replaced it with something else, and reinserted the other stuff, I guess. But yeah, you could technically do it. It's just a lot of calling methods like delete one character, and stuff like this. But it is possible technically. Yeah. Yep.
Do you know if it's possible to customize any of the keyboards? For example, I'd like to be able to customize the Chinese keyboard. Does Apple have any APIs open for that?
So not as far as I know, and they're really protective of their keyboard, honestly, because it really is much more privileged than the custom keyboards. So one of the, actually, I could go back and just show you, I actually copied the sentence from the documentation where Apple sort of explains what the custom keyboard is for, and I think they mentioned something about languages. No, sorry, so that was somewhere else. But basically they said that it's for providing novel text input and providing text input in languages that Apple doesn't support. So they explicitly said that basically this custom keyboard API is also for people that want to provide, input in different languages. But unfortunately, I don't think there's a way to sort of keep some of theirs and build on top of it. You either have to go all in, really, and build everything, the whole stack, or you can't do it at all, which is one of the reasons why there's not that many companies. There's like 5 or 6 companies that seriously do this, the full typing keyboard replacement for the Apple keyboard.
How do you support multiple languages?
So basically, we have an SDK, which a different team in our company makes, and the way it works is basically it loads up both of those languages and just make one data structure from it. And because it sort of understands the context of words and how they follow each other, whenever you start writing in English, the predictions start being in English and corrections start being in English, and then I switch to Czech, and suddenly in the models, the context information again is Czech. But technically, if you actually wanted to write a sentence that's a Czech word, English word, Czech word, English word, Swift would learn this eventually and then predict for you this mix of languages. But yeah, it's basically just making one big structure from both models, really. Yep.
Can you tell more about memory mapping? Because are you still using the ARC?
We are using ARC. Memory mapping, it's a C call, so it's a very low-level call. But we actually use it in our SDK, which is in C++. So, sorry, to your question, then no, we're not using ARC in the same code or in the same source file. But since it's a C call, I think you still should be able to mix it with Objective-C the same way. So I haven't really tried this, but I think even if you use these calls in C, you would have to call free on that file at some point, or on that object later. But you could still do it in the Objective-C file. I haven't tried it. Any other questions? Yeah,
Cheeky question.
Yeah. it's the best ones.
Are there any chances of getting Welsh on that?
Actually, I just learned about it for the first time now, so I might actually talk to the team. And why not? Because we really try to. I think there are some sort of layouts and languages we support that Apple doesn't. So we really try to make sure that like if there's something we can do really relatively easily and build for more people, then really it is. Like SwiftKey Android right now supports over 100 languages, so that's more than Apple, more than Google, really. So it's something I can really bring out, but maybe just support our support team as well, because they take everything and actually aggregate it and stuff. So if you want Welsh, definitely just hit our website swiftkey.com and just go to support and request that, because we're looking at those a lot when we think about what we're building next. Yep.
You said with the Derby notifications to be able to kind of cross-process
Yeah.
stuff. If I have an app running, can I listen to Derby notifications that you're sent? Does it go broadcast to that?
Yeah. So.
Targets?
Yeah, I haven't actually tried it between apps that are not from the same developer. So I have to create a new Apple ID and go that way. But I think it's the same one as with what's it called the share container. So basically, you have.
It does work because
It does work. Okay.
Text expander does notifications, so
Okay. Yeah. So it's only there can be in a payload, but yeah, I guess if you sort of agree, all apps agree on the same string, then I guess yeah. Thanks. I didn't actually test it across apps from different developers. So yeah, it might be possible. It's very low level as well, so yeah, it makes sense.
Do they have access to camera?
No. So camera and microphone are two things that we can't even request access to.
You can't put your face on a keyboard.
Yeah, you cannot, unfortunately. So those are the two things we can. Camera, I mean, you could do something crazy with it, like showing what the camera's showing, and you could type and look, where you're walking, I guess.
You could
But,
make a GIF out of your own face.
Sorry?
You could make a GIF out of a selfie. I'm sure that would.
Yeah, I
so
mean,
well.
I'm sure there would be a good ways, but unfortunately that
That is
isn't.
good to do with scan text. Do the OCR insert into text field?
Yeah, that would be a good one, actually.
So let's say thank you, Jim, again.
Yeah.